Okay, hello class. I'm going to solve one extra question from session 4, which is going to be question 6. Let's read this question. A 1 foot diameter, 2 foot long cylinder floated in an open tank containing a liquid having a specific weight gamma. So we have a cylinder floating, and from this figure we can see that because it's the level of the water and the cylinder, they're at the same level, so the weight and buoyancy is supposed to be exactly same value. Okay, so this is the first information we found from this figure. Then the gamma for that liquid is not given, and we don't know what is the gamma. A U-tube manometer is connected to the tank as shown in the figure below. When the pressure in point A, which is at the end of the manometers, U-tube manometer, is 0.1 psi below the atmospheric pressure, so negative, and because it's a negative, it means it's a gauge pressure. For absolute pressure, it's always positive. The various fluid levels are as shown. Okay, these are the information we have. Determine the weight of cylinder. So we need to find the weight of cylinder. To find the weight of cylinder, we need to find buoyancy, because buoyancy for this arrangement is supposed to be exactly same as weight. We have the size of the cylinder, but to get the buoyancy, we need to know the gamma for the fluid, and we don't have it. And to get gamma, probably we are going to use this manometer. Okay, let's start working. So this is question 6. And this is my cylinder. And the weight of the cylinder, which we call it W, supposed to be equal buoyancy force FB. So we can say that summation of forces at y direction, so let's consider this is y direction, must be equal 0. W is equal FB, and FE is gamma for the fluid. This is for solid times area. So gamma pi divided by 4, 1 foot diameter, oh, I made a mistake here. This is times 2 foot length. So this is going to be pi gamma divided by 2. Okay. So we found FB, which is equal W. Excellent. Now we need to write down the pressure in the manometer. Let's take a picture of this, and we can use it here. Okay. So let's start from the left side. left side we have liquid with specific weight of gamma. That's it. We don't know any other information. What is the height? It's this height. So the first one is going to be gamma times 3.5 foot. Okay. Now I'm here. Same height, same liquid. We need to jump this side. Then we have the pressure because of this liquid, which specific gravity is given. Minus, because we're going upward, Sg, whatever is that, times gamma water times the height, which is going to be 2.5 foot. Then we have pressure because of this height of water. Again, upward is going to be negative gamma for water times the height, which is 1 foot, and it is going to be equal this PA. Let's plug the numbers. So gamma 3.5 gamma minus Sg is 1.5, 62.4, 2.5 minus 62.4 times 1 must be equal negative 0.1 psi, so I need to convert it. 12 times 12 inch square to foot square, so basically I convert it to pound per foot square. So the only unknown is gamma, therefore gamma is going to be 80 pound foot cube. Now I can plug the numbers and get the weight. So W is equal pi divided by 2 times gamma, 127 pound. So for this question, you need to investigate the figure we have. The first point given was the situation of the cylinder. Cylinder was floating, so the weight supposed to be exactly same as the buoyancy force, and buoyancy is gamma of the fluid times volume of the solid. That is the most important part, and don't make mistake here. And that is supposed to be equal weight. So we found one formula there, but gamma was missing. To find gamma, we wrote the pressure balance inside the manometer. Okay, thank you very much. See you next time.